out on that question. So
Yes,
thank you for bringing that up.
it's again, it's not the best worded question in what they're trying to get you to do, but basically they're just saying, okay, take your data and find the average of your data. And for some strange reason, instead of calling it X bar like we always call it, they call it Y bar.
Okay.
So let's just say we took the average of all the circumferences of these trees. Have you actually done it? Because I don't have it off the top of my head.
Let me see if I have.
I thought it was like 7.2 or something like that. If that rings a bell.
It looks like I have not figured that one out yet.
All right, I can just run the data right now and get it. All right, so here's 3. Wait.
I'm so jealous that you're like, let me just do this right away. Not a problem. 3 seconds. Because it's not. I can write till the cows come home, but this is not. This is just anxiety ridden for me.
Well, yeah, we always have our strengths and weaknesses, right? For me, I almost failed French, so that was what killed me in college. All right, so here is 330, right? Those are tree stuff. So I'm going to go down here to my tasks and utilities and do my summary statistics. And I'm going to choose my import data and add in my analysis variable, which is just number. And then for my options, I just want the mean and standard deviation. So I'm going to turn these other things off and go ahead and run it. So there's my mean and my standard deviation.
See, when you're doing it, it seems very easy.
It is. That's the beauty part of
I think I'm reading too much into it and I'm making it more than it needs to be.
And that's a very common thing. Students always do that in this class. It's a very, especially since, like I've said before, this is a doctoral level class, right? So everybody thinks that, okay, so it needs to be doctoral level stuff. Not always, sometimes it's 5th grade stuff. I mean, it really is just that simple.
I've not taken stats since 2000, just as an FYI. So It's been a long time.
Yeah.
So then in 369, they're talking about a scatter. And thank you for this. That
well, let me finish this off because this is going to throw a lot of people for a loop.
Okay.
Okay, so we ran the data and we got, I'm just going to put 7.2. I can't remember what it was. I think it's 7.2. And then the standard deviation of our sample, I'm just going to say is 1.3. You guys are going to have to use the real numbers when you get to it. But when they tell you to do, so in the homework, they ask you, let me get this, somebody's typing something. Make sure I'm looking at my chats. Yes, I will do that in a second. All right, so let me get this out of the way so I can see. When it lists this, y bar plus and minus s, that really just means that you're doing an interval where you take the mean, you add the standard deviation to it, and you subtract the standard deviation from it, and that's where you get your 2 numbers. So you're going to have y minus s, and of course now my computer just froze. Come on.
I had class last night and like 4 of us had our computers actually boot us out during class. So technology is a wonderful thing when it works.
Yeah. Well, okay, here we go. All right, so let's try this again. So you're going to have basically y minus s comma y plus s, right? So this is going to be 7.2 minus 1.3. So of course that's 5.9, and then 7.2 plus 1.3 becomes 8.5. So that's the first interval. Then the second interval is going to be, y bar plus and minus 2 s's. So you're going to subtract 1.3 twice and basically get 4.6. And then you're going to add 1.3 twice, right? And basically get, what's that, 9.8.
So I'm sorry to back up for just a second. So you're saying it's 7.2 minus 1.3 minus 1.3.
Right. Well, so this is our first interval, and then our second interval is supposed to be the same y bar, but now we're going to add and subtract 2 times our standard deviations.
Okay.
So it's just going to be 7.2, right? minus 1.3 twice, because that's 2 times 1.3.
Gotcha.
So that's just going to be 4.6. And then, of course, when you add it twice, you're going to get 9.8. And then, of course, the third one, same thing, right? We're just adding and subtracting it 3 times. So now we're going to be down to 3.3. And this is going to be what, 11.1. And then what you're supposed to do, so these are your 3 intervals.
Mm-hmm.
Then you have to go into your data and count up how many data values in your sample fall within this interval. Well, now, since everything was whole numbers, right? So obviously you're looking for something bigger than 5.9, so 6, and less than 8.5. So you're going to look for 6, 7s, and 8s. Those are the only ones that would fit inside this interval. So you'd go through your data, sort your data, and count up how many 6, 7, and 8s you have, and then divide that by the total number, which was, I think, 50, and that'll give you a percentage. So you'll get some sort of percentage of your data that falls in this interval. And then you do the same thing here, right? So between 4.6 and 9.8, so it's got to be bigger than 4.6. So obviously the smallest one's going to be 5, and it's going to be smaller than 9.8. So obviously the biggest one's going to be 9, because again, we only have whole numbers in our data set. So you're going to count up all the 5, 6, 7s, 8s, and 9s, divide by 50, get a percent for this one, and then do the same thing for this last one, right? Everything bigger than 3.3, so obviously 4 all the way up to 11. So 4 through 11s, you count up all those and get a percentage for that. And then you're supposed to compare these 3 percentages to the empirical rule. And the empirical rule tells us that if you have a set of data and you go out 1 standard deviation in both directions, which is what this first one is, that should capture what percentage of our data? Who remembers what the percentage of that one is?
I don't remember.
Anybody else?
68%.
Very good. 68.
What is it?
68.
Yep.
And then if we go 2 standard deviations in both directions, it gives us
95.
nice, 95%. And 3 standard deviations gives us
99.7.
You guys are on it, 99.7. So you're going to compare your sample to the empirical rule and discuss if it's close or if it's far off and that kind of thing. So that's 330 in a nutshell.
So can I ask a really just tactical question then? So this absolutely clears this up. Thank you. What are you looking for us to give you? Are you looking for a code? Are you looking for just this scribbled out? What are you looking for in the homework?
I never need to see code unless you want to show it to me because you did something really cool and you want me to copy and put the code in the SAS how-to, and at that point, but basically, if it asks you to construct these intervals, you could just put these 3 intervals with your percentages on them.
Okay.
Obviously, for part B, it wants you to calculate the mean and the standard deviation. So you could either, type those into the Word document, or you could do a screenshot of this little box and put that in and go, here's my mean and my standard deviation.
Okay.
But because, since we no longer force you guys to use SAS, you don't have to prove to me that you did it in SAS. You could just write these numbers down.
Perfect. Thank you.
Yeah. Yeah. Okay, what else?
The other one that I had was 3.69, the scatter plot.
Oh, yeah.
Okay, that doesn't make me feel good when you say it that way.
Well, it's just, it's teaching this course 20 times, people ask about this 20 times. It's just one of those questions that always comes up. Okay, so 369, let's get that data in. Run that. All right, so then it wants you to construct a scatter plot, but it also, let me try this again so I can read it. Everything's in the way, my other screen. Okay, here we go. So construct a scatter plot, compute the correlation, and then does the value reflect the degree, and all that. Okay. So, you could do this in bits and pieces. If you wanted to, you could just go down here to scatter plot and double click scatter plot. And then, choose your data. the x-axis, and it says construct a scatter plot of the number of AIDS cases versus the number of syphilis cases. So that normally means you put X and Y in the order in which they say it, right? So when they say AIDS versus syphilis, then that means AIDS should be X and syphilis should be Y. And then you can just literally just run that. And then there's your scatter plot, right? And you could take a screen grab of this, and that's good to go. But it also wants you to compute the correlation, right? So you could fit the regression line to it if you wanted to, and put that, but that still doesn't give you the regression, right? It just puts a line on there. So then maybe instead of just doing the graph, you could come down here and you could look at, well, correlation analysis. I could run that. If I double click on correlation analysis, and then I put in AIDS correlates with syphilis and run that, well, then I'm going to get the correlation. So in this little box, there's my correlation. But I can also go and just run linear regression and kind of get the whole thing all at once. But, and here's the thing, guys, linear regression, the linear regression tool is a little less than user friendly. So I'll show you what I mean. If you wanted to try and get it all at once, I personally would just say, screw it. Just run the scatter plot, run the correlation analysis as two separate things, and you're good to go. Because those are both very cut and dry, easy, double click, put some stuff in, run, and you got an answer. They're very intuitive. They're very easy to understand. If you wanted to actually run linear regression, which will kind of do everything for you all at once, it's okay. It's just it's got this one little extra thing. So first of all, instead of having like X variable and Y variable, it has this thing that's called the dependent variable. What the hell is the dependent variable, right? Well, the dependent variable is a fancy way of saying the Y variable, right? The output. And so again, if we're going to correlate AIDS versus syphilis, then because syphilis is listed a second, syphilis should be the dependent. And then it's got classification variables versus and continuous variables. And this is where it gets tricky. You're going to want to put your stuff in as a continuous variable because that's what it is. It's these are scores, right? So they're continuous things. Classification variable would be if you had like a grouping variable kind of thing. Okay, so you've got those two things. Well, you'll notice that the running man is still grayed out. You can't run it yet. So you got to click on the model and go, oh God, now what? All right, well, you got model effects. You have to edit your model effects, and you just have to tell it to add in that one variable and then hit OK. And then now you'll see the running man is there. And if you go to options, you can do all sorts of cool things where here's your scatter plot, right? And you can fit a plot for a single continuous variable. There's all sorts of stuff where you can do confidence intervals and things like that. So it's a more robust thing. And when you run it, you get everything all at once.
Yeah, I'm going the other way.
Yeah, I think the other way is easier as well. But so
this is a lot.
Here is your R squared, which you didn't get from correlation, but if you know what R squared is, it's literally just your correlation squared. So you could just take your correlation and square it to get R squared if they ever ask for R squared, which sometimes they do. And then here is your scatter plot with the fitted line. And then it gives you a bunch of extra crap that you don't care about. Right, so you don't have to worry about any of that stuff. So, it is a way of getting everything all at once, and it also gives you R squared. And the really important thing is it gives you your regression equation down here. And I think it also lists it. Nope, that's the only place it lists it. So if you wanted to, let's say, make a guess, so if you had, remember, it's all based on, what's the input and what's the output. So in this particular, syphilis is the output and AIDS is the input. So I don't know what these things are in particular. I don't know what the numbers represent, but I think it's number of cases. Yes, number of cases per state. So you could say, if the number of AIDS cases in a certain state was blank, estimate the number of syphilis cases, you know, that kind of thing, then you would have to use this for your regression equation. And you have to understand how this works, right? So these are your parameter estimates. The whole idea behind regression analysis is to be able to do predictive stuff. And this is what allows you to predict these numbers, because we're now basically saying that we can predict syphilis is going to equal you know, AIDS cases times this number, 0.58814. Gosh darn it. Just the touch on, touch off. All right, stop doing that. And then plus this intercept of 150.25. Oh, I've really had it today with this technology. 25713. Okay, so that is where you would be able to estimate. So you could put in number of AIDS cases, do this simple math, multiply it by this, add this to it, and then it'll spit out number of syphilis cases. I personally would go the other way. I would think it would be more likely that you would want to look at number of syphilis cases and try and predict number of AIDS cases. But because it didn't give you any clear-cut directions in 3.69, we normally just go with the order in which the variables are listed. But that's 369 for you. And I'm with you, Sherry.
Thank you.
I would do the simple scatter plot and then the simple correlation, because unless they actually ask you to compute a regression equation, there's no need to have to do linear regression.
Okay.
All right, who's up next? Anything else?
I think somebody mentioned 3.3C earlier.
Oh, 330C?
Yeah, 330C.
Yeah, we already did that one. That was the first one we were doing.
I had to log off and log back in, so I'll rewatch the video. I apologize.
That's all right.
So can I ask another? I'm sorry, I don't mean to ask so many questions, but I don't want to bother you after this class. So
Sure.
On the mini project that's due Sunday, there is you give us information data, and then it talks about let's see if I had an answer or question here. Generate at least 2 different cross tabulations.
Great question. Cross tabulations always should be done with qualitative variables only. So you have to pick 2 of your qualitative variables and do it with those.
Okay. Perfect. Thank you.
Yep.
And with those variables, the questions seem almost arbitrary in terms of which variables we choose. Do you just want us to show you that we know how to do the procedure, or are there particular variables that you're looking for us to choose?
Well, I want to make sure that you know how to do the procedure, but I want to make sure that you also know which is a qualitative and which is a quantitative variable. So
Got
in
it.
that data set, you know, there are both, and you need to make sure you're choosing the right ones.
Got it. Thank you.
Yep.
Can you give an example of what is in this data set, which is the qualitative versus quantitative?
In what data set? In the
mini project for the cross tabulation.
Sure. So
I mean, for example, I picked age versus genetic history or family history.
age is a quantitative variable, not a qualitative variable.
Okay.
So this one. So if we look at our variables in our data set, we have treatment gender, family history, age, BP before, and BP after. We technically also have this subject, but subject is not a variable. It's a descriptor, right? I mean, this is literally just saying what subject they are, D1 through, you know, and then C, blah, blah, blah. That's, subject is not a variable at all. So it's neither qualitative nor quantitative. It's literally just
What group they fell into.
exactly.
Yeah.
So you have, in this data set, you have 3 qualitative variables and 3 quantitative variables. Your qualitative variables are treatment, gender, and family history, because all they do is describe a quality, right? Even though treatment has numbers, ones and zeros, those ones and zeros really just mean like yes and no, whether they got a placebo or an actual drug, right? Treatment versus placebo. Exactly.
Okay.
And then gender, of course, is just a descriptor with F and M. And then family history is a descriptor with 4 or 5 categories. I can't remember off the top of my head. I think it's 5, where you got
Yeah, it's basically what paternal or maternal or whatever.
neither or both.
Yeah.
Yeah, so I think it's 4. Yeah. So paternal side, fraternal side, right? Paternal, maternal, neither, or there's a both sides. Yeah. So 4 categories there. So those are your 3 qualitative variables. So when you're doing those cross tabulations, you have to do it with these variables. So you could do like treatment versus gender, treatment versus family history, or gender versus family history. There's only 3 different cross tabulations you could do, right? Because if you have to choose 2 of the 3, you can only leave out 1. So you only have 3 choices for which one you can leave out. And then of course, anytime they ask you to do something with quantitative variables, you only have 3 quantitative variables to choose from, and that's age, BP before, and BP after.
Okay, thank you.
Yep.
That's super helpful. Thank you.
Of course.
That's
What
all
else?
I have, so I'm going to scoot. But thank you and have a wonderful Thanksgiving, everyone. And I hope you all stay safe as these
Yes.
weird times are going by.
Thanks, Sherry. You too.
Thanks. Bye-bye.
Bye. Tyler?
Yeah, I'm sorry. I was spaced out for a second. I was writing down some notes. So anyway, that was very helpful. Thank you.
You're very welcome.
And thank you for looking at my last assignment. I'm getting more of a grip on this. Before I had like a very loose handle, and I'm getting more of a grip on it. I appreciate your help.
You got 5 or 6 threads. Pretty soon you'll have a whole handful.
or it'll be stuck to my face or something.
That's right. Yeah, exactly.
Like waking up, after you fall asleep with a lollipop in your mouth, and you wake up and it's.
Yep.
Anyway, thank you very much, and
of course.
You have a great Thanksgiving.
Thanks, Tyler. You too.
All right. Bye. We'll talk to you next week.
All right. Bye-bye. Anybody else have any other questions?
I don't have any questions. I just want to thank you for the information, and I'm going to sit in front of my computer, cut a piece of turkey, and then look at this
yep.
and keep going. But thank you so much. I'm clear now. I had some
Sounds
questions,
good.
but
You're welcome, Cassandra.
Thank you. Have a good one. Bye-bye.
Thanks, you too.
Thank you. Good night.
You're welcome, Liz.
Oh, and sorry for being such a pain. This class just freaks me out.
Nobody is ever a pain. Nobody ever has to apologize. This is what I do for a living, and luckily I enjoy it. So I am more than happy to help. Yeah.
Thanks.
You're
Have
welcome.
a great holiday.
Thanks,
Bye-bye.
you too. Well, if nobody has any other questions, I'd be happy to go through 30 part C again, so you don't have to watch the recording for that person who had asked about it. But I'm surprised there aren't any other questions.
No, I'm good. Thank you. Happy Thanksgiving. I'm going to turn in my mini project, and so hopefully I'll get feedback from you soon over the weekend.
Sounds good.
Okay, thank you. Happy Thanksgiving.
Thanks,
Stay
you too.
safe.
All right, you too.
Okay. All right. Bye-bye.
Bye. And then there were 3. Any questions, folks?
No, sir. I think I understand everything. I've been going back and reviewing from your last class as well. So I think good to go.
Yeah, those old videos can be very helpful because, like I said, you know, if I teach it 20 times, people are going to ask the same question 20 times. So usually you can go back and look at what people asked last time, and it's going to be the exact same questions you're going to be wondering about.
Yes, sir. Thank you so much. And happy
Absolutely.
Thanksgiving.
You
Thank
too.
you. Bye-bye.
Bye. I'm going to ask a silly question. Is the mini project typed out? Okay, so technically the mini project is supposed to be a little bit more of a report and less like the homework, as far as, you know, you're not just handing in a bunch of answers, but it still is pretty much just a bunch of answers. The only real big difference is it asks you to kind of interpret some things. So wherever it says, you know, justify or interpret and those kinds of things, make sure that you're elaborating. That doesn't sound right. Make sure that you're giving some more details than just an answer. So let's see, mini project. Double checking the question or the questions here. It says generate this, find that. I thought it was at the very end, the very last one. Oh yeah, so the very, it's of course, once again, I think we do a horrible thing of this course does a horrible job of really describing what it wants. It says at the very top of the mini project, the purpose of this project is to assess you on your abilities to summarize data numerically and graphically using SAS, which we no longer require. You can use whatever technology you want, to interpret these summaries within the context, and to present the results as a written report or oral presentation. So interpret these summaries within the context. That's kind of important. So you're not just spitting out an answer, you're then discussing it just a little bit, right? We're not looking for, you know, lengthy prose. This thing, including, you know, any graphs and scatter plots and all that kind of stuff, probably wouldn't be more than 6 pages long, and that's, you know, mostly graphs. If you took out all the graphs, it would probably be maybe 2 pages tops, double spaced of prose, you know, words. So it's just, you know, when it says, like, well, for instance, when it says part A, generate frequency tables for 3 categorical variables, there's really not much you can do. Generate those 3, and then I would say, just give me 1 sentence describing what you see. Are there any patterns? Is there anything interesting about any of them? So that's kind of what a quote unquote report is. It's, here are my results, and here's a quick 1 or 2 sentences describing those results, kind of drawing your attention to something. So here's my scatter plot, and then I'm going to go. You'll notice that there's not a great pattern to it, and you'll see that you know, it tells you that there's only a weak correlation, which is supported by the fact that when we run the correlation, we get, you know, 0.4 or something like that, you know. So it's just a real quick blurb to kind of interpret your results. So I know that not only can you run this stuff in Excel or SAS or whatever you're doing, and you can actually get a result, but you can actually discuss it formally so that other people understand what the hell they're looking at. Because the whole point of this class really not only is it to make sure that you understand a little bit about stats and understand how to use technology to run some stuff, but it's all building up so that when you do your dissertations, you can have statistics in your dissertations and you can discuss your results. So it's that kind of thing, but obviously it's not on that same level, right? You're not turning in a mini dissertation. So a sentence or two here or there describing your results, pointing out interesting things, pointing out important details, summarizing stuff. So like when they ask you to run a bunch of summary statistics on everything, well then discuss them. Was there anything interesting about those? Was one thing different from the other two, or were they all relatively the same, or did something stand out? That kind of stuff. Does that answer your question? You're welcome. Anything else? Okay, well, one thing I want to point out, in case I didn't point it out in last term's videos when people are watching these videos back, is for your data sets and the project files, you'll notice that for the mini project, there are two sets of data. There's the new drug data, which is the full set of data that you need to answer. You need to use this set of data to answer all of the questions except for one. There is one question in the mini project, and it is part E, where it says generate a side-by-side box plot to compare the variables. Now, of all of the people who have sent me their mini projects ahead of time and asked me to look at them, I think every single person did part E wrong, because they just did two different box plots and then just stuck those two graphs next to each other in Word. That is not what a side-by-side box plot is. In order to do a side-by-side box plot, you have to use this data, the BP categorized data. And I'll show you what I mean. So here's BP categorized. I'm going to run this and replace it. And if you look at the output, all of my BP data, I no longer have separate. So for instance, on the mini project, you have a variable called BP before and a variable called BP after. In this set of data, which I created for you guys, I took all of those BP scores and I put them under one variable called BP. And then I made a secondary variable called BP cat for BP category. And so this 78, this blood pressure reading of 78 was an after score, right? And the 80 was an after, and so on and so forth. And then you can see as we go down, here's a before. 87.5 was the BP before. And there's another before, and so on and so forth, right? So you have just all of the numerical data under one variable, and then what's called a categorizing variable, which in this case is the BP cat variable. You have to have your data set up this way in order to do a side-by-side box plot, because to do that, you then have to go to the box plot task, right, under graph, choose your data, and in this case it was under import 2. Your analysis variable is going to be the BP variable. So you have to have one variable that has all the data in it. You couldn't use the original data set because you would have to choose, BP before and BP after separately, and then you're going to get two different box plots. And you don't want that. You want two box plots, but you want them in one graph. You would get two separate graphs the other way. And then, so you use your BP as your analysis, and then what you have to do is you have to use a category variable, and that's where you put in the BP categorizing. And when you run that set of data, That's how you get two box plots together in one graph. So that's how you can do part E. It does not work if you just go to this data set, right? Use this normal data set, and this is in import 3. And then, darn it. I double clicked on it and now my window has changed. I don't know how to get it back. There we go. So here's my data. It's in import 2. And now if I go to my box plot and I put in my analysis variable of, sorry, it should be import 3, I think. Yep. And put in BP before and run it. I'm just going to get this one all by itself, right? And this is what everybody did. They got this one, they caught this, they pasted it into their thing, and then they took this away and they put BP after, and they ran it, and they copied this one. No, that's not a side-by-side box plot. The whole point of a side-by-side box plot is to get them both on the same scale, right? So you can see how they line up. You can see that before, right, is everything in before is shifted up. So all of these scores are on the whole higher than these. So that's how you can compare those two groups and get that answer. So that's the only other thing I want to make sure I mention, because a lot of people were getting that wrong. Okay, anything else before I call it quits since nobody has any questions? Okay, I'll take your deafening silence and non-typing in the Zoom chat to mean that you're all good. So just be sure and watch the video, both of tonight and last time. If you have any questions, post things to the doctoral dialogue, and then you know, at some point try and enjoy a little time off for the holiday, even if you're not in the States and don't normally celebrate Thanksgiving. Take at least a day off and enjoy some family time. All right, guys, I will see you next week.